Okay, so today I'm going to be teaching you how to do Dalton's law, which can also be called Dalton's law of partial pressures. So, Dalton's law, basically, in chemistry and physics, Dalton's law, which, like I said, can also be called Dalton's law of partial pressures, states that in a mixture of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressures of the individual gas. So, some key points you want to remember in Dalton's law is the pressure exerted by an individual gas in a mixture is known as its partial pressure. And then, assuming we have a mixture of ideal gases, we can use the ideal gas laws to solve problems involving gases in a mixture. And Dalton's law of partial pressures states that the total pressure of a mixture of gases is equal to the sum of the partial pressures of the component gases. So, Dalton's law of partial pressures is a gas law that can be stated as P total equals P1 plus P2 plus P3 plus Pn, where P1, P2, P3, and Pn are the partial pressures of the individual gases in the mixture. So you would use P1, P2, P3, and Pn to set up your equation to solve the problem. So here's a problem, an example problem. So the pressure of a mixture of nitrogen, carbon dioxide, and oxygen is 150 kPa. What is the partial pressure of oxygen if the partial pressures of the nitrogen and carbon dioxide are 100 kPa and 24 kPa? So to set it up for this example, you can simply just plug the numbers into the equation and solve for the unknown quantity. So you would put P1 equals P nitrogen plus P carbon dioxide plus P oxygen. So then you get 150 kPa equals 100 kPa plus 24 kPa plus P oxygen because you still don't know the oxygens. So then you would do P oxygen equals 150 kPa minus 100 kPa minus 24 kPa, and then you get your oxygen, which is P oxygen equals 26 kPa. And that's basically how you solve a Dalton's law problem. You just plug in the numbers into the equation and solve using P1 plus P2 plus P3 plus Pn.